Please let me know if my screen is visible to you or not.
Visible, sir.
Okay, so right now I've just opened the same process. I've opened the software, so you can just open the software and click on schematic editor, and then in schematic editor you will find the recent schematic files. So already yesterday I have saved the file in the name of DFIG WECS, Wind Energy Control System. So I'll just click onto it and open that file, and then we'll continue from the part which I have left yesterday. So make it open. Okay, so now we have done the modeling for this plant, and we have taken some go-to blocks up till this part we have done for this grid connected meter, right? So now we need to start from this part. We have not given the value for this inductor and resistor, and up till this grid. And then we'll develop a controller for it, for controlling the DFIG, for providing torque for this DFIG, as well as for giving the uh, of this PWM for this, which is over here for this back-to-back alpha. So let's start. I think this file has been opened already. Just if I had missed anything, please let me know.
Sir, please show the value of chopper.
Chopper doesn't have any value, only I have changed the control source as model. That's it.
That's it. Okay,
Yeah.
got it, sir.
So now I'll start giving the parameter for this inductor and resistor. So I'll just double click onto it. Give inductance as LGSF. I'll define it as LGSF, and the resistor as RGSF. So you can just select it, copy it, and paste to the remaining resistor as RGSF and the inductor as LGSF. Copy. So value of inductor is LGSF, and I have defined the value for the resistor as RGSF. So which I'm going to define later onwards using this model response. Now what I'll do, I'll just enable this control for this contactor. In the software itself, I'm not going to turn on and off this contactor through SCADA, so I'm going to control this this contactor and that side contactor also through this develop the control over here. So I'll just double click onto this contactor and select control source as model and feedback output as true. You need to select control source as model and feedback output as true because we require the feedback output of this contactor. Rest everything would be remain same, only control source would be module and feedback output would be true.
Done, sir.
Now I'll just move to this side, which was left as this. We do not require the output of this wind power plant meter, so I'll just disable it. So how to disable it? You can disable it from this side. Enable output put. You need to deactivate it, and also I need to change one thing is execution rate. So here execution rate would be TS. Rest everything would be same. Execution rate as TS internal jobs. Also you can enable the voltage current, which I'm going to frequency, which I'm going to require later onwards, or I can enable the power reservoir. So I've enabled the frequency and power only, and here I've changed the registration rate as TS and disable the output port. So if you click on OK, now you will see this output port has been removed from here. So in this meter, I have only deactivated the enable output port option. Rest everything is okay. Only the excitation rate I have changed from 100 e to the power -6. So whenever you will find excitation rate in any block in this model, you need to change it to TS. So that's constant. Next, voltage is already enabled, current is already enabled, frequency I have enabled on my own. And the next thing I have enabled is this power measurement. So I have enabled the frequency and power measurement. Okay. So that's the settings I have done. So next I'll just do the settings for the transformer. So after you're done, please let me know. Okay. So now I'll provide the parameter for transformer. So I'll just double click onto it and provide the parameters. So here I'll take SN value as 4 e to the power 6. I'll change it to 4e6. Frequency as 50. That's okay. And P1 as 10,000 divided by square root 3. NP dot square root. I need to write in this. Okay. And V2 as 690 divided by NP dot square root.
Sir, actually, I
Yes.
have seen it in various times that we always write np dot square root, np dot something, or np dot uh,
Yes. Yes.
percent.
Yes.
So why should we write? Means what is the benefit? Means why we use this np? Is it a format type thing, or what is that? I don't
What is
understand.
one thing I'd like to ask in these days? Yeah, one means what is the background of the software?
It's
Do you know
Python.
what it? Yes. So
So
for
np
Python,
is numpy.
yes, exactly. NP is
Okay.
NumPy.
Okay.
I
Thank you,
think
sir.
you got it. Yeah.
Yes.
So
Yes.
NP.
Yes.
So that's why everywhere whenever we write any pi, something we declare any pi or we declare any square root, or there are various functions are there. So that's why we need to call the numpy library of Python. So that's why we need to write as np.py or np.square root or like this. That's the reason.
Sir, many times I find it, and because I think it's not good to ask these type of things, because
Okay.
it's a very simple thing. But this
Yes,
time I
yes.
think it's quite good to understand. Okay, thank
Yes,
you
yes,
very much.
exactly, exactly. It's better to clear your queries. So now I change this PSC values from 2350 to 280, and then rest all of the same. Yeah. So these are the changes I have done for the transformer. SN is 4 into the power 6, and then V1 as 10,000 by NP dot square root 3, and V2 as 690 by NP dot square root 3, and PSC as 380. This is the changes I have done over here. One thing I'd like to add over here, basically everywhere, means in this constant block or gain block, whenever you need to write any pi or square root, then you need to write np dot square root. But if you write declare pi in C function block, then you do not need to write np dot pi over there, because it is not based on Python. Yep. Its syntax is different. Its syntax is similar to C. So that's why you do not need to write over there as np. Okay. So that's the difference. So please let me know if you're done up to now.
Done, sir.
Okay. So I click on OK. And now this grid parameters is left. So I'll just provide the RMS voltage as to the 30 volt 50 hertz. And I'll click on OK. So now this part is left for this meter. So here I'll just put this meter. And I'll just change the action rate first as PS. I require the output port because I need voltages and the power from here, from this meter. So let me check. Okay, this voltages are enabled. I'll enable the frequency as well as I'll enable the power measure. Okay, and then click on port. Now from here I'm getting voltage, current, power, and frequency, all these things. So to split it out, I require a meter split. So for that, I will go to MicroTech and go to meter, and I'll take meter split. And I'll double click onto it, and I require the voltage as well as the power. So I'll enable the power, active and reactive power. Okay, and I've just enabled the phase voltage and the power, active and reactive power, and I'll click on OK. Now from here you will get the port for power as well as the voltage. So now again, similar way, I need to take a bus join, I need to add these voltages, and I need to add this power. But in controller, when we develop the controller part, we need to again take a bus split, and then we need to separate those signals for the individual purpose. So first, let's use a bus join. So for that, I need to go to this system. So I take one bus join, because I require. Let me just hide its name. And increase the number of output for the first as 3. So the second 2 is required one. So I'll just connect it. EAN, EVN, this. And I'll just connect the power. Now I'll take go to block and connect with it to take the output. So I'll just take go to block. Here go to. I require to go to blocks. So first I'll drag and drop and hide its name and provide the tag as grid underscore BA and scope as global. I'll get it as a global and click on. From here I'm getting the voltage, and I'll just copy this go to and paste it over here and change the tag name as power measure. So I'll just name it as power underscore measure and connect it. So do this part now and let me know, then we'll move forward. After that, we'll create a subsystem for this part, we'll test it and bus join. Yes?
Sir, please show the general value of grid meter.
Okay. So in grid meter, what I have done is I have changed the execution rate first as TS. Okay. I'll show only the change. Rest is default. This phase voltage is already enabled. ABC current is already enabled. Only thing I have enabled is frequency and power.
Okay, sir.
And after that, what I have done, I have taken a meter split over here, connected with it. And in meter split, I have taken this phase voltage measurement, VN, VBN, VCN, and now and also enabled this power. So that's why you have seen over here this voltage and power is appearing. Okay. Then the same way we have taken the bus join and taken a go-to block and take out the signals from here.
Yes, sir. Got it.
Okay, so up till now, is it done from everyone or should I wait?
Done, sir.
Okay, everybody done or no one is following? You can start again if you have left and joined later onwards. So you can start again and I'll help you.
So can you show the wind plant meter setting?
Wind power meter, plant meter settings. Here, only thing I have done change is this execution rate. I have changed to TS. Okay, and nothing.
Yes, sir.
Only I have enabled the frequency and power. Okay, frequency power I have enabled, and uh, here I have disabled the output port and changed the execution rate to TS. That's it. After
Yes, sir.
clicking onto it, first change the execution rate as TS, then disable the output port, and then next what we do is enable the frequency and enable the power. That's it. Okay. So
Yes,
up till now, is it done or should I explain it once more? The values, the parameters which I have taken. Is it done? Should I move forward? Yes or no?
So move forward. Done, sir.
So now we have left these two things. We need to take the output
Sir,
of this contactor.
sir,
Yes.
I'm not
Yes.
getting the chopper. Where can I find?
Chopper is not there in the library. You need to take a contactor over here. I have taken a contactor, single pole, single throw contactor. Okay.
Okay, sir.
Yes, it's single pole contactor. I have just renamed it as chopper. So now what I'll do, I need to take out the state for this contactor, the status side contactor and this rotor side contactor. Okay. So I'll take the state by using go to block. So again, I need to take the go to block. First, I'll do for this contactor over. Now both are in one frame. So I'll take a go to block and connect with it. I'll hide its name. And provide the tag as RSC underscore state. And scope as local. Here only thing is I'm doing is I'm not making the scope global. Previously I've taken all everything is global, but right now I'll take the scope as local. You are taking the feedback output of this
Scopes are
contact.
local,
Yeah, scope is local,
not global.
not global. So previously for every block, for every code block I have taken as global, but right now I'm taking this as local.
Okay, fine.
So for this contactor, both this contactor, I'm taking out the feedback state for this contactor. So done for this part, and now I can copy the scene and paste it over there. And I'll just flip it. And here, instead of RSC, I'll just type over here as GSC underscore state and scope same as local.
Excellent.
So here I have taken the feedback output as RSC underscore state. And here I have taken the feedback output for this contactor as GSC underscore state. For both this photo block, I have taken a scope mode as local. So from right now onwards, I'll take every photo block then status scope status as local instead of global. Done up till now.
So GSC state,
Yeah,
state
GSC underscore
also scope
state.
is local.
Local.
Understood.
From now onwards, for every photo block, it will be local.
Okay, sir.
Yeah. So done up till now.
It's
Yes, sir.
So now we'll develop the controller for wind turbine, and then we will develop the controller for this both converter. So first we'll start developing the wind turbine control. So we just I'll place my controller over here, design my controller over here instead of this one. So first I require for my controller wind speed. The most important thing for this DFIG is I require a wind speed. So for wind speed, I'll take a SCADA input. So what is the advantage of SCADA input of taking it for wind speed? Anyone from the UG students? What is the advantage of SCADA input block? I need answers from UG. Yes, UG students. If you cannot unmute yourself, then you can just type on chat box. But you need to answer, or else I'm going to mark absent for you guys, because you guys just join over here and then do not do any activity, just go blank over here. So answer or go with me. Make this class much more interactive. So anyone from the UG side, what is the advantage of SCADA input? Yeah, I know, sorry. I know that you guys know very well regarding that. But I just asked the UG students, because what happens, they just join over here in a training program and do not go through the activity. Control and maintain efficiency. Uh, no, not actually control and maintain efficiency. The benefit of taking SCADA input is that in real time or during runtime of simulation, you can change the parameters online without stopping simulation. So that's the advantage. So that's why we are taking wind speed over here as a SCADA input. Okay, so that's the idea. You guys do not need to worry about your answers. It's okay. You can give wrong answers also. That's not an issue. But you need to answer. You need to respond. So right now, as required, I've taken one SCADA input, which will work as my wind speed. So I'll just double click onto it and change its name for my representation as will underscore speed. So using this, I can change my wind speed. And also one thing you need to keep in mind, that whenever you're taking SCADA input block or you're taking constant block, then you need to change the execution rate, because it contains the execution rate. So here I change the execution rate from 100 to the power minus 6 TPS. So first I require this wind speed. So for wind speed, I have taken a SCADA input, and in SCADA input, I have changed the execution rate as TS. And next parameters I require is this mechanical speed from the motor. So from here, I'll get the mechanical speed. So for better purpose, I'll take a from block. So you can just search on library section and drag and drop from block. Okay. So first I have taken a SCADA input as wind speed, and then I have taken a from block. So I'll just hide its name first and change the tag properties as mechanical underscore and scope global, because I have taken global over there, so I need to use the same scope as global, and click on OK. So let's check whether it's tag or not. Yes, you can see the matching tag as go to.
So
Yes.
repeat the value of a SCADA input.
I have not changed any values for SCADA
Only
input.
execution.
Only the execution rate would be same TS. Just note it down in a
Yes.
paper that for all blocks, the execution rate would be same. It would be as TS. Okay. So now I require another input. So this input is to enable and disable this DFIG. Okay. So for that, I'll take another SCADA input, because in the runtime, I want to turn on and turn off this DFIG. So that's why I'll take a SCADA input. Okay. As mechanical speed is a measured value, so I've taken a go to block over here, and then I've taken a from block. But right now, to turn on and off and to change the wind speed, I have taken the SCADA input in that purpose. So I can either you can copy it from here and paste it, or you can just drag and drop a SCADA input and use that. So I'll just copy it and paste it over here and change its name as DFIG underscore enable. Inside it, every value would be same. Only thing I have changed the name of this SCADA input block, DFIG underscore enable. So now also I require the state for the both contactor, GSC underscore state and RSC underscore state. So for that purpose also, I'll just copy this from block. I'll copy it from here and paste it. And I'll change the name from mechanical speed to GSC underscore state and scope as local, because I have taken local over there. So I'll change it as local. Similarly, I'll copy it from this same from block and paste it over here. And only thing I'll do, I'll change the name as RSC underscore state. So first I have taken SCADA input as wind speed, then I have taken a from block as mechanical speed, which and scope as global. Then I have taken the SCADA input to enable and disable the DFIG. So then I have taken the GSC state from this contactor, sorry, this side, and scope as local. And then I have taken RSC underscore state, also scope as local.
Sir, will you please enlarge the screen?
Okay, I just zoom this part. Is it visible now?
Yes, sir.
Yes.
Okay, done up till now.
Yes, sir.
Okay, now do one thing. Just take a digital probe. So I'll just drag and drop our digital probe and connect with this port. I'll change the name for this digital probe as back to back switch underscore state. So I'll change its name as back to back switch underscore state. Change its name like this. Take a digital probe and change its name as back to back switch underscore state.
Sir, instead of writing back to back switch, we write B to B switch state.
You can write, but keep in mind you need to remember that because when we are developing the SCADA part, we require this signal over there.
Okay,
Okay.
sir.
So whatever you write, it's upon you. It doesn't need that whatever I have written over, you need to write at that same point of time. So you need to remember that whatever the signal you have taken at this point of time. Okay.
Okay, sir.
So next, what I'll take another digital probe over here and connect with it, and I'll change its name for this digital probe as break switch state. Okay. Just make some space over here. So first I have taken as back-to-back switch underscore state, and then for GAC state, I'll just take a digital probe and take it as break switch underscore state. Done up till now.
Yes, sir.
So now I'll go to signal processing and I'll take a logical operator and I'm going to double click onto it and change its operator mode from AND to NOT. I'm going to connect it to this and then to a digital probe. I'll hide its name and connect a digital probe. And I'm going to change the name for this digital probe as data switch underscore state. So these are the three consecutive digital probe I have taken. First, I have taken back-to-back switch underscore state. Second, I have taken break switch underscore state, and then I have taken a logical operator, change it to not, and then I have made it as data switch underscore state. Done up till now?
Done, sir.
Okay, now I'll take another digital probe to see this signal, DFIG another. Okay, and I'm going to change its name as DFIG DFIG underscore EN. So all over 4 digital probe I have taken. Now I require a C function block to calculate the zone for the wind. So for that, I'll go to functions and tables, signal processing, function and tables, and I take a C function block. I'll hide its name, right click and hide its name. Now for this part, I require input from wind speed, mechanical speed, as well as J. So I just double click onto it. Up till now, it is done now. I should do the configuration for C function block, or should I wait?
So it's done.
Okay. So now I'll just take first input as wind speed. So I'll type over here my first input as wind speed. Now second input as omega underscore m, and the third input as j, and the fourth input as DFIG underscore nf. These are the 4 inputs I require. Wind speed, omega m is my mechanical speed, j is my inertia, and then DFIG underscore nf. Now, done up till now, wind speed, omega underscore m, j, and DFIG underscore nf. So now I'll move forward.
Sir, third one is Z.
J.
Fourth, DFIG dot
DFIG
under
underscore enable.
EN.
En. Yes.
Okay, sir. Done, sir.
So now I'll move to outputs. Yes.
Sir, in digital probe, we have
No
written,
settings.
sir, in digital
Yes.
probe 4, which is added to DFIG enable, we have written DFIG in capital letter. Here we write DFIG in small letter.
It's okay. It's okay.
It's okay.
It's okay. No need to worry about that.
Okay.
But here, if I write any code and that is capital, then I need to match with it. Else, it will not get matched with the input. Okay.
Yes.
As it is outside, so no need to worry about that.
Okay, sir.
So I'm going to make the label for this, so it will be easier for me to understand. So label it out and click on OK. Close anyways, and you can see the input is over. I just enlarge it a little bit. So now you can see these inputs are visible over here.
Sir, for output, only out.
No, I have not written the output code. Only I have taken the inputs and click on OK and close it. So
Okay, sir.
here I just want to show the difference that how means if you label it out, then you will see these options over here, so that it will be easier for you to understand.
Okay,
Okay,
sir.
so let us just connect the wind speed first. So here I need to put a limit over here, rate limiter block. So I'll just type over here, or I can take it from here also. Discrete rate limiter and connect with it. I'll just double click onto it, change the limit from 2 minus 2. Okay. So I'll click on OK, and next I'll take this mechanical speed to omega m, and this DFIG enable, I'll connect with it, and I'll take constant over here for J. So for constant, I need to go to signal frequency, and here I need to go to the sources. So from here, I'll just drag and drop a constant block first, and hide its name first. Then I'll just double click onto it, change the value as J, and execution rate as yes. The value would be J, and the execution rate as yes. This value for J I'll define in the model initialization. So I'll click on OK and connect. Okay, done up till now.
Done, sir.
Yes, everyone.
Yes, sir.
Yes, sir.
Okay. So now I'll move to the output side for the C function block which was left. So I'll double click again once again and go to output, and the first output would be my speed reference. I'll just type over here as speed reference, and the second output as zone, and third output as DFIG underscore EM. So these are the outputs, and I'll just enable the label of it: speed reference, zone, and DFIG underscore TM. Speed reference, zone, DFIG underscore. Okay. Now in variables, I'll take as TKR. Outputs as speed underscore reference, zone, and DFIG, and variables as TKR. So done up till now. Yeah.
Done, sir.
Okay. So now I'll go to functions, and first we'll start with the initial function. So I'll just give the value zone equal to 0, and the speed underscore reference would be equal to 0, and DFIG underscore TM would be equal to 0, and PKR, the variable which I have taken, would be equal to 22,000. I just copy and paste the value to the chat box. Now we'll move to the output function section and we'll write the code. So first, bracket wind speed, wind underscore speed is less than equal to P.
So,
Yes,
so we have taken speed reference zone DFIs in output of general outputs.
yes, zone
Yes,
and
sir.
DFIG as output and speed reference also as output.
Okay, sir. And in function we have put it in input function
Yeah, yeah. We'll
declared. Okay, sir.
declare data, initial
Declared.
values it is. Yeah, yeah. Then in output function, we'll write DFIG underscore enable not equals to 1. This is the first condition. If wind speed is less than equal to 3 and DFIG underscore enable not equals to 1, then first condition zone would be equal to 0 and the speed reference underscore reference would be equal to 0 and DFIG underscore EN would be equal to minus omega underscore M in G. Condition of course. If wind speed is less than equal to 3 and DFIG underscore enable is not equal to 1, then zone would be equal to 0, speed reference would be equal to 0, and DFIG underscore TN would be equal to minus omega underscore M into J. This is my first condition, first output condition. I'll paste this code into the chat box, so no need to worry about that. Okay. Now, second condition, else if wind speed, wind underscore speed is greater than 3 and wind speed is less than equal to 5. Then zone would be equal to 1 and speed reference, speed underscore reference would be equal to 80 and DFIG underscore EM would be equal to 1000 into wind speed minus 3000. This was my second condition. Now I'll just type third condition, else if wind speed zone or whatever zone selection 0, 1, 2, 3 represent, I will declare it on the next function block. Okay. So next, else if wind speed is greater than 5 and wind speed is less than equal to 10, then zone would be equal to 2, speed reference would be equal to 5, 5.115 into wind speed plus 4.4424 and DFIG underscore m would be equal to 1800 into wind speed wind underscore speed minus 7,000. This was my third condition for zone 2, and now I need to define again for zone 3, zone 4 and zone 5. Okay. So I just copy, you can also copy it and paste it. It would be easier to write. So the next condition is if wind speed is greater than 10 and less than equal to 22. First it was greater than 5 and less than equal to 10. So zone would be now equal to 3 and speed reference would be equal to 1008 into, just move this part, into 2 into 3.141 divided by 60. So for zone 3, speed reference would be equal to 1008 into 2 into 3.141 divided by 60. And DFIG would be equal to 916.66 into wind speed minus 1833.3. So this was my zone 3 calculation. And next, just enter and paste the same code for zone 4. So now for zone 4 declaration, if wind speed is greater than 22, and less than equal to 25. So this is for my zone 4. So I'll now change it to zone 4 and speed reference would be equal to 1008 into 2 into 3.141 divided by 60 divided by 60. Same for zone 4, the speed reference would be same and DFIG underscore TM would be equal to 22,000. The same value for the TKR. So now the last condition, else zone would be equal to 5 and speed reference would be equal to 0 and DFIG underscore TM would be equal to minus omega underscore M into J. Now let's check syntax.
Sir,
Yes,
sir, for zone 4,
yes.
speed reference is 1008 into 2
Into
into.
2 into 3.141
Okay, sir.
divided by 60. The whole divided by 60. So I'll just copy this code and paste it in the chat box.
Sir,
Yes.
can you please explain this code?
First, we have taken the wind speed. We have taken the whatever the wind speed difference we are selecting. Okay. So if wind speed is greater than 3, then DFIG enable, and DFIG is not equal to 1. Enable is not equal to 1. Okay. The zone would be 0 and speed difference would be 0. The initial condition. This condition is also for the zone 5. What is zone? I'll just develop a C function block that how to calculate zone in the later onwards. Okay. And then I have taken the speed reference and DFIG uh, measurement for means the torque for the DFIG. I have taken it for per zone, zone 1, zone 2, zone 3, and zone 4. Okay. So for first condition, if wind speed is greater than 3 and less than equal to 5, so this comes under zone 1. Then greater than 5 and less than 10, zone 2. Then greater than 10 and less than 22 under zone 3, and greater than 22 and less than 25 under zone 4. So these 4 zones I have taken, and then I have taken the speed reference. So first I have taken speed reference as 80. Then you need to calculate is as per the wind speed, and then this is the calculation for 1008. You need to calculate actually. I do not know the proper value, so you need to calculate. Okay. And then DFIG torque would be 22,000 for the zone 4, the maximum speed. Okay. And else zone 5 means there will be no wind. What is zone 5? I'll declare it later onwards. Okay. So then speed reference is 0 and torque would be minus omega m, which is my mechanical speed into J inertia. Okay. Is it clear?
Sir, but wind
Sir,
why less than 3? Wind speed should be less than 3. And why 3?
Oh, I didn't get your point actually.
So why we have taken that if wind speed is less than equals to 3, means why the number
It
3
it
less
is
than
it
3?
Can you
is.
please speak little louder?
I think
Sir,
you are
I was
asking that.
asking. Yes, sir.
Yeah, if wind speed is less than equal to 3, right? Then
Yes,
why
sir.
I have taken the speed difference as 0 in that case?
I mean, sir, why are we comparing first with less than 3 and then with greater than 3? I don't understand that.
We are just assuming the let's take an example for wind turbine. Okay, actually we are developing the model in reference with that. So zone 0 means there is no wind speed. So wind speed I have taken less than 3 in that case. 3 means what say? I'm just forgetting the term
Wait.
for this. Yeah.
Actually, see, the things are here compared with the three and it's 5 different sections. There are those are categorized in different zones. So each zone having their own speed preference means certain ranges. So say in first one that is less than 3. So in that case, zone 0 is going to act, and in this case, the speed difference is going to be 0. So when this speed difference is going to be 0, so at that instant, the DFIG is going to produce this torque, okay, minus omega into inertia. When speed is going to increase and it is going to come up in the range of 3 to 5, then your zone 1 is going to active. So in that case, a different speed difference is going to be inserted. If you compare on zone 0, so speed difference is 0, and in case of zone 1, the speed difference is 80. Okay. So as per the standard wind reference, wind speed reference, there is around 40 to 12 to 14. But here, see, that is as per standard. But what we are trying to do here, we are going in more depth so that we can make a turbine to work on low speeds also. So the speed zones we have categorized, and as per but those zones are not going to work with the single speed difference. Therefore, with different zones, different speed difference have given. Is it fine?
Okay, sir.
Okay. Sir,
Sir,
Yes.
sir,
Yes, sir.
only half part of coding is in chat box.
Okay, okay, okay.
Only zone 3 till zone.
I'll paste the entire.
sir,
Yes.
Sir, are these zones to get the maximum power out of the turbine? So
Ye
we are changing the.
yes.
Yesterday we saw that at different wind speed there are different curves, and we skip from one curve to another to get the maximum point, maximum power point.
Of that to provide the torque to our. Yes, yes, sir.
Actually, you are absolutely right. This is for optimization. Okay. So when we use different zones, so different speed difference are going to be inserted so that we can get maximum power. Okay.
Okay, sir.
Okay, I have pasted the zone 4 and zone 5 code in the chat box also. You can copy and paste and let me know. Done up till now?
Sir, wait 2 minutes.
Okay, okay, sure, sure, sure. Please let me know if anyone is having any error in their syntax.
Done, sir. No, sir. It is.
So I'll click on OK. And is anyone having any syntax error onto their code? Please let me know.
No, sir. Copy paste.
So now I'm getting the speed reference over here. So I'll just connect probe onto it. So I'll just drag and drop on probe. And connect with it. From here, I'm getting speed reference. So I'll just type over here WRM underscore reference. And now from here, I'm getting the torque. But here in this model, I need to compare this torque with active power as well as reactive power torque control. Okay. So for that, I'll take a gain block. So I'll take a gain block. I'll hide its name, and its value would be -1. Okay. Value would be -1 only. Someone mic is turned on. Can you please mute yourself? Okay, so first I have taken a probe and connected with this speed reference, and I've changed the name for the probe as WRM underscore ref. And then I have taken a gain block and connected with this port, and here I have given taken the gain value as -1. And now I'm going to take a signal switch. Signal switch. And connect. So here I'm going to control this torque with active power control and active power control torque. So for that, I'll take for reference for that part, I'll take to SCADA input. So I'll just take to SCADA input. And for the first SCADA input, I'm going to change first direction rate TS. For both, it will be direction rate would be TS. Just everything would be same. And I'm going to change its name as active power control. And this one as active power control underscore torque. Please let me know if you're done up till now.
Done, sir.
So now I'll require one C function block for this zone. Okay. I'll go to single processing and again functions and tables and try to drop one C function. So I'll first hide its name. And here I'm going to take the zone. So I'll just directly going to connect it, the zone part. So first my input is zone. So I'll type it as zone and label it out. So my first input is zone. And then I have labeled it out. And my output is wind underscore OK. And I'll label it. Input is zone and output is wind underscore OK. Okay. So my input is zone and output is wind underscore OK. And I'll now write the function. So if this is output function, not initialization function. So if zone is equal to 1 and zone is equal to 2 and zone is equal to t and zone is equal to 4. Then in that case, wind underscore OK would be equal to 1 and condition close. Else if for zone 5, for zone equal to 5, then wind OK, wind underscore OK would be equal to 0. Else wind OK would be equal to 0. So for zone 1, zone 2, zone 3 and zone 4, wind OK would be equal to 0, means it would be turned on. And else for zone 5, it would be 0, and for any other condition, it would be 0.
Sir, for zone 3 and zone 4, only equal to, yeah, double equal to.
Oh, sorry. Let's see syntax. I'm going to copy this code and okay. So after completing, please let me know. Then we'll move forward. Done up till now.
Yes, sir.
So I just enlarge this block in this way so it is really visible, zone and window. Okay. And now I'll just do the settings for the signal switch. I'll just double click onto it. The settings will be if control is greater than equal to threshold and threshold limit I'll set as 0.5. Instead of 0, it would be 0.5. So now I'll take a product block. So I'll go to math operation and I'll take a product block. I'll hide its name. And this one I'll be connecting this. It would be in this way. Since I've taken a product block and uh, this output for this window okay and this DFIG enable. This output is to enable the contactors as well as to enable our converters, back-to-back converter. Okay. So if I just keep the signal as enable, then it will turn on along with this part zone section. Okay. Else it will be turned off. Heads up motive also.
Sir, after C function block,
After C
zone,
function block, I have taken a
only product.
product block. Okay.
Okay.
And I have connected this window okay and this output of this DFIG one.
Okay, sir.
So now I require some edge detection block. So for that I'll drag and drop this edge detection which will find in logical operation. Just hide its name. I'll copy it and paste it. And I'll take a SR flip-flop block. So I'll just take one SR flip-flop. After product block, I have taken edge detection block and then I have taken a SR flip-flop block. Okay. Done up till now.
Yes, sir.
Now what I'll do, I'll change the settings for this edge detection. Instead of both, I'll make it as rising and click on OK. And this one as falling. And now I'll connect. And this one with the SR. I'll hide the name for the sub block. Initial value, I'll make it as 1. Okay.
Initial value, sir?
As
1.
1. 1, yes. Done up till now?
Yes.
So now what I am going to do, I'll make this entire part in a subsystem. Okay. So I'm going to select it from this rate limiter part, this side, this section, up to this SR part. In this way. First see it, then we need to do. This rate limiter, J means our inertia block, and this part would be inside my subsystem. So I have selected this part up to this SR part in this way. Not this part, this wind speed, mechanical speed, DFIG, NFO, GSC state, RSS state. Instead of this one, I have selected from this part up to this SR. Okay. So after selecting it, just right click onto it and click on create a subsystem from source. Okay. So now you can see the subsystem is created. So I'll just make the adjustment properly. So these are my input ports, and we will need to create the output port also. So that will create later. Okay. Done up till now. You need to select that part and right click onto it and click on create a subsystem from search. Hello, sir. Sir. Okay, sir. I'm in meeting, so I'll just call you later on. Okay, sir. Sure. Is it done up till now?
Done.
Okay. So now I'll just configure this input blocks over here for the subsystem. So I'll change the name of it. Instead of IN1, I'll name it as wind underscore speed. This is my wind speed. So wind underscore speed. Okay. Now next is my omega underscore m. So I'll name it as omega underscore m. And let's check left 1, left 2. Now next I'll change the name of it as DFIG underscore enable. And after that, setter underscore state. And back to back state.
Sir,
Yes.
Sir, how do you create subsystem? Means how many block have you selected?
I'll just show you once. See, here there are various SCADA input blocks, constant blocks are there. So I've taken from this rate limiter. I've taken from this rate limiter and selected in this way up to this SR flip flop. Okay.
Okay, sir. Thank
So
you.
in this way I have selected. Means not this part. This part I have neglected and selected, and then afterward I have created the subsystem.
Yes, sir.
So last one is back-to-back switch state.
Back-to-back underscore state. This is switch state, the digital
Yes.
probe, but this is back-to-back underscore state. Okay.
Sir, can you show once rate limiter properties?
Rate limiter
For
property
to
is 2 under 2 and minus 2.
okay, sir.
So any other doubt? Done up till now?
So no change in index of DFIZ status state.
Nothing. Inside properties, no change. Only the name has been changed.
Okay, sir.
I have changed the name as wind speed omega underscore m, DFIG underscore enable, stator underscore state, and back-to-back underscore state.
Done, sir.
So now I'll just delete this output part because it has configured automatically, but I need to do manually. Only this part I have done manually, and then after I create a system, so it's okay. But here I need to create it manually. So for that, take system. I need to take single output port. So I'll go to system on this side and on this side. I'll search. The first output I require my speed reference. So I'll connect with it. And here I'll change the name of it as speed underscore reference. So this is my first output port would be speed underscore reference. I have taken a single output port and connected with this speed reference out. Okay. And now we need to configure the index and each and everything. So here I'll configure it on write and first. So I configured it as write and first. Done up till now. Okay. So now I'll take the second output port and place it over here and connect with it. And I'll rename it as T underscore mechanical MECH. Okay. So in this part, and this index would be right and 2. Okay. T underscore mechanical, which I have made in short, T underscore mech, and index would be right and 2. Okay.
So why we remove all the initial output and
To for easier, actually we need to edit that part. Okay. So that's why for in case of no doubt, that's why I removed. But if you want, you can do that also. You can configure
it is
it.
not necessary to remove all the output.
No, 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 it is not necessary. But here in this case, to means do not go for any confusion. That's why I have
Okay.
removed and then I have done one by one. Okay. That's why I have taken removed all this and first taken first signal output port, named it as speed reference, and then given the index. Previously, there was no index over here. Okay.
Yes, sir.
So now second, I have taken this T mechanical as my second output port. Okay. And now next output port I require for this, I'll connect over here and change the name as back-to-back switch. Back-to-back underscore switch. And I'll index it as right third. Okay. This was my first speed reference, then this was my second, and this was my third. And now I'll require two output port. Okay. So I'll just drag and drop one and another one. So this I'll name it as stator switch, stator underscore switch, and click on OK. And this would be my right port. So first, second, third, fourth, and this one. I'll change its name as break and right side fifth. First, second, third, fourth, and connect this with the Q output and this one with Q. Okay. Done up till now.
Thanks, sir.
So now let's have a break and then we'll meet at 4:30. Okay. Let's have a 15 minutes break. Okay. Then we'll meet at 4:30. Hello and welcome everyone. I hope my screen is visible and I'm audible to you.
Hello, sir.
Yes.
Sir, actually, I have closed the schematic and again opened it, and I'm getting this error. Unhandled exception has occurred, and all the blocks has been scattered.
All the blocks have been scattered.
Yes, sir.
Have you saved that or
Yes, sir. I have saved the file.
do one thing, close and reopen it once again and see whether the error is resolved or not. Because sometimes it occurs actually. Depends. Yeah. Okay, is my
Sir,
screen? Hello.
yes, sir.
Yes. Yes.
Yes, sir. Sir, I'm not getting here the port on not get. When we create a subsystem, then we will get input port and output ports. So at the not gate and in the down there is a one digital probe. At that point also I'm not getting any port. I tried to select all.
No, this is digital probe over here. I have not taken any output port.
No,
This
sir, that
see,
stator state is a port now.
this
And
this one,
back,
no, this one.
yeah, yes,
See,
sir.
first I have what I have done. I have taken here SCADA input. Okay. Then I have taken a from block. If you see, remember the previous circuit. Okay.
Yes, sir, I remember that. Yeah.
Then then I have selected this part only. This part, not this side. I have not selected this part. I have selected this part and then I have created the subsystem. After creating the subsystem, this port will be there. IN1, IN2, IN3, IN4, IN5. In this way, it will be there.
Sir, I tried the same, but for that not for, for the not loop and as well as back to back switch
What
state,
is
there
what
should
is
be
what is available over here?
not nothing is coming.
Is it this go to block or from block kind of thing, or
Sir, please zoom the screen.
is it like this way? Is it coming in this way, like this from block, or nothing is there?
Yes, sir, it's coming like that.
Yes, inside the system because we have selected this both also. That's why it is coming. No issues, in order to worry. Do one thing. Just make this GAC state as global instead of local. Make it as global, and this RSS state also as global. Okay,
Okay, sir.
do that, and you need to do one thing also here. In these two contactors, you need to make this one as global and this one as global both. Okay.
Contactor also global.
No, this one, this go-to block. Here I have taken scope as local now.
Okay.
You need to make it
Okay.
global. Make it,
RSC and GSC
yeah, both,
should be
both
global.
global. Here it
Okay.
will be global, this two will be global. Then your problem will be resolved.
Okay, sir.
So do it and let me know, then I'll start. Okay. So now what I'll take three digital probe. One, Mhm. And so I have taken 3 digital probe, 1, 2, and 3. Done up till now?
Yes, sir.
Okay. So now what I'll do next is I'll rename this digital probes. So first I'll rename this first digital probe as RSC enable, and this one as TSC enable, and this one as RSC enable, GSC enable, and WIC. So these 3 digital probe I have taken and changed the name. Okay. So now I'll go back to root outside the subsystem. Take this and increase its size. I'll adjust all the component which I have taken. And I'll just change the name for the subsystem as wind turbine controlled. Just zoom to this part. And I'll take some from block and connect to this output port. So I just take from block signal from liquid, hide its name, and my first tag would be WRM underscore reference, and this scope I'll make it as global and click on the thing. So everything would be global from now onwards. I'll make everything global, and I'll copy this, paste it over here. I require 1, 2, 3, 4, 5. So 5 I'll paste it, and then I'll change the tag. So first it was WRM underscore reference. Second is DFIG underscore EM. Third is GSC enable. GSC underscore enable, and port is RSC underscore enable. And fifth is break. So first is WRM underscore reference, second is DFIG underscore PM, third is GSC underscore enable, fourth is RSC underscore enable, and fifth is break. And I've changed the name for the subsystem as wind turbine controls. And all the scope is global, no local. Everything is in global. Okay. Please let me know if you're done after that. Then we'll move.
Hello, Sudipta sir.
Yes.
So I think by mistake you have taken from tags. I think those are go to at the output. Please check.
Okay. Yes. Sorry.
Yeah.
Actually, it sometimes creates some confusion over here. Okay, thank you for that.
Yeah. Welcome, sir.
So instead of from, I require a go to block over there. So I'll just take in go to and change the name WRM underscore and scope as blue. Copy. And I'll change the name first. DFIG underscore PM, and this one as GSC underscore enable, and this one is RSC underscore enable. Previously, I've taken from block by mistake, so we need to take use go to. So please let me know if you're done.
Done, sir.
So now from here I'm getting GSC enable and RSC enable. So we are going to utilize that. Also, I'm going to use this DFIG torque, which I need to provide to this machine over here. So now let me just zoom out a little bit. First, I'm going to provide a torque, which is coming from here, DFIG underscore TM. So now I record the from block. So I'll take a from block, place it over here, and I'll hide its name, and I'll provide a tag, which is DFIG underscore and scope as global. Let's check it is tagged or not. Yes, it's tagged. So I'm sending the signal to this. You can directly send the signal also, but we make the circuit proper. That's why I've taken this.
Sir, from tag. No?
Yeah, we have taken from tag. Here it is go to. We now require a from. Okay. So we have utilized this signal. Now we need to utilize this two. Okay. This two will utilize for the measurement part, the speed reference and the break for the measurement. Now we require to utilize this two outputs. One I have taken over here. So now I'm going to take the signal from, place it over here, hide its name, and this would be my RSC underscore enable. And scope as global, because I've taken global over here. Let's check it's tagged or not. Yes, it's matched. And I'm going to connect it to this. So the same signal, RSC underscore enable, this one I've taken onto turning on this contactor. Also, I'm going to use the same signal to enable this three-phase back-to-back converter, this one. So I'm going to copy this and paste it over. I'm going to turn it in this way and cut. Okay. I have taken this status switch signal output RAC underscore enable connected to this part and this one. Make sure whenever you're connected the from block, your tagging is matching with the respective go to block. Okay.
Sir, same from block.
Yeah,
Added
same.
RSC enable.
Yeah, I copied it and pasted it over here and connected with it. This enable port, the first port. Done up till now?
Yes, sir.
Okay. So now, similarly, we need to give signal to this converter and the this contactor. Okay. So now it's done for GSC enable. So I'll copy this same from block. Already it's copied, so I'll just paste it over here, and I'm going to change its name as GSC instead of RSC enable, and connect with this. Let's check. Yes, it's matching. Similarly, I'm going to copy it from here and paste it over. This enable this command. So we have taken the output, developed the swing turbine control, and given the torque to this machine. Also taken two outputs, speed and angle over here. And from here we have taken the state for the both contactors. Okay. And then we have also given the control for this both contactors. Control set. Okay. Also to turn on and off this back-to-back converter, we have given the enable signal also. Now,
Sir,
yes,
can you please show the properties for S1?
S1 model and true.
Okay,
And
thank you.
here, yeah, okay, model and true you need to do. We require to keep the signal for this controlling of this contactor, and also we require the output feedback output. So that's why we have taken the control sources model. So you will get the input port, and then if you make the feedback output true, then you will get the output. Okay. Now, what is left is this for giving this control signal for this back-to-back converter, INA, INP, and INC for this both, and also the signal for this chopper is left. So we need to develop that. Also, we need to measure the power and voltage, etc. So for that, we need to develop the control part that is left. So now what we'll do, please let me know if you're done up till now, then we'll start the next.
Sir, wait two
Done,
minutes.
sir.
Sure. I'll wait. Sure. I am done. Okay, done up till now.
Yes, sir.
So one thing I have done over here by mistake, that here you need to rename it as omega m underscore speed instead of omega rm underscore speed. Okay. So that's the change. That's a small change. And also here I have forgotten to make it in a subsystem. So I'll just select this part, this meter split and burst join, and right click onto it and create a subsystem. So that's the two changes to forgot. Now you can do it. So these the two
Sir,
changes. Yes.
sir, there are no matching tags for this WM underscore ref.
Yes, it will not match because we have not taken any
Sir,
from block,
speed.
right?
Sir, speed या REF? WM underscore?
WM underscore speed only,
Not REF.
not REF. WM underscore speed. Actually, it is not matched because we have not taken any from block to connect with it. Now we'll take. Okay. Someone mic is turned on. Can you please mute yourself? Okay. So now we require various from block to take the signals and develop a controller. Okay. So first we'll require these all the voltages or the currents we have measured from this meter. Okay. So let's take from block and place it over here and hide its name and change the name of the tag as RSC underscore I A B C. Check the tag. It's not matching. Okay. So yeah, I forgot. It need to be global. Scope as global. So now it is matched. RSC underscore IABC. We have taken this signal over here. That's it's RSC underscore IABC and scope as global. Similarly, I'm going to copy this one and paste it. The same property, only I'll need to change the name as GSC underscore IABC. Let's check the tag. Yes, it's matching. Now again, I'm going to copy and paste. This time I require GSC underscore DABC. Let's check. It's being local, so I need to make it local. So I have named it as grid VAPC. Let's check. Yeah, grid VAPC. So I'll rename it as grid VAPC. Let's check. It's matched. So both three is matched now. Now again, I'm going to paste another one, and this would be my mechanical speed. So I'll just name it as MECH underscore speed, and then I'm going to copy this and paste it. This would be my mechanical angle. checked or not. Yes, it's done. Speed and angle I have taken, and then I'm going to paste another one here. I'm going to change its name as VBus. Uh, this voltage over here, VBus. That's it. It's matched. And now I require another one as the power which I have measured from the three-phase meter, which I have tagged it as power measurement. Next, this signal speed omega m underscore speed. So I'll just leave it as omega m underscore speed. Okay. Yes, it's matched. And another one is GSC state. This is it's let's say it will local. This. So these are the signals I require. So first it is RSC IAPC, GSC underscore IAPC. Okay. Then a grid underscore VABC, mechanical speed, mechanical angle, VBus, power measured, and omega underscore speed, this signal, and GSC underscore state. Okay.
Sir, power.
Power underscore measure. So after means giving the name of it, check whether it is tagged properly or not. Else it will create problem later.
Sir,
Yes.
sir, where was the go-to tag for WM underscore speed?
Here. This one.
Okay.
So that's why it's matched over here.
Sir, what is GSC state scope?
This one, JC
Yes.
underscore state, it will be local because we have taken for this contactor over here JC underscore state as local. That's fine. Okay.
Okay.
Make sure whatever the scope you are taking, it is matched properly. Then we are going to do the work. Done up till now.
Sir,
Yes.
if we create GSC state global. Is there any problem?
No problem. But you need to make both as a global in that case.
Okay.
Okay. Whatever the signals you are getting from the conductor, you need to make that one global also, and this one as a global also. If I put this inside a subsystem, then if I make it local, then it will create a problem. But in case of global, it is not an issue. Okay. So now we'll move forward. We'll just separate the signals which we are getting, and then we are going to measure it for PLL purpose. Okay. So first, now we'll require bus speed. We require bus split, and I'm going to hide its name. And here, from this, I'm getting three signals. So I'll make it number of output as first one as IA, second one as IB, and third one is IC. Okay. So now I'll take go to block and connect it over here. Hide its name. So this would be my RSC underscore IA, scope as global. I'll copy it, paste it. Should be my IB. And next, this would be my IC. Okay. In this way. Everything is having the scope as global. Okay. Done up till now. Please let me know if you're done or not.
Done, sir.
Okay. So same way I need to do for this GSC IABC, read the ABC in this sheet. At the downward side, make some spacing over here. So I'm going to copy this and paste it over. So instead of RSC IABC, I need to write over here as GSC IA, GSC IB, and GSC IC. Similarly, I'm going to copy this. Already copied, so I'm going to paste it once again. Now this one, I'll rename it as grid underscore VAN This one would be BBN, and this one would be this. In this way. Please let me know if you're done.
Done, sir.
Okay. So now what I'll do, okay, I'll just take the PLL of this currents and the voltages. So I'll take three-phase PLL, three-phase PLL, and I'm going to change its settings as disable, make this disable DQ filter as true. And also one thing I need to do in others, I need to disable this sine omega t and disable this 0, DQ 0. Disable the both. So it will be in this way.
Sir, can you please show the ABC to DQ property in this three-phase PLL?
Here I have taken this disable DQ filter as true, and in others I have just disabled this both.
Okay, sir. Done.
I'll hide its name. And now I require this go to blocks. Sorry, from blocks actually. So I can copy this same from block.
Sir, please once again show the properties of PLL.
Yeah. In this PLL, I have made no changes. Only this disable DQ filter would be true instead of false. And in others, I have disabled this both.
Okay, sir.
So now I have copied the same from block RSC IABC and paste it over here. And now I'll just change its name as RSC IA and I'll get the same. Let's check it's connected. Yes, it's connected. So I'm going to copy this and this over here. RSC IP. Next one as RSC and let's put RSC.
Done, sir.
So I require only this D and Q. So for that, I'll take a bus join and connect with it. I'll hide its name, and here I'll place a go-to block. So I'll copy this go-to block and paste it over here. So I'll first change its name as RSC underscore IDQ and correct it.
Sir, it's go to block last.
Yeah, it's go-to block. After bus join, it's go-to block. Okay. So now the same thing I'll do. I'll do one thing. I'll just copy this part entire and paste it over here. And in case of RSC, I'll take this grid voltages. Okay. So this would be my grid underscore VAN grid underscore VBN and then grid underscore PC. You might be thinking of we can connect it directly, but if we connect it directly, there will be a lot of hotspot. That's why to avoid that, we have done this. Okay. I just copy and paste it and change its name. That's it. And here I'll just rename it as UBQ underscore grid. And also I require to connect for this frequency and omega t. So I'll just copy this same, paste over here and change the tag as grid underscore frequency. And I'll copy this and paste it over here and change its name as grid underscore grid v underscore theta. Connect to this point.
So can you please show the last go to that?
Grid v underscore theta.
Done, sir.
Okay. So now what I'll do, I'll take I'll just do one thing. I can just Yes.
Sir, please show last go to UDQ underscore grid.
UDQ underscore grid underscore frequency, and grid V underscore theta.
Okay, sir.
One thing I'll do over here, just select this part. Instead of using PLL, I'll use ABC to DQ. Or drag and drop one ABC to DQ block. And connect. So only instead of PLL block, I have taken ABC to DQ.
Sir, please repeat this part.
Previously, I have taken PLL block over here. So instead of PLL block, I'll use ABC to DQ. And I'll take this theta signal and place it over here. So I'm going to copy this and take that. Yes.
That PLL part is wrong.
Yes. Instead of PLL, I have taken this ABC to DQ transformation.
Another part left remaining. Tom tag first.
Sorry? Yes, this one, right? Yes, here I'll find the theta underscore R. We'll assign this signal theta underscore R later. Okay. So connect with this omega t theta underscore. Okay.
Sir?
Yes.
Sir, your theta underscore R is connected to C.
No, it's not connected to C. It looks like in this way, but it's not connected. Okay.
Okay, sir.
So done. Now what you need to do, you need to just copy this part and paste. This I'm going to use for this GSC IABC. Okay. So instead of RS, it would be GSC IA. This one would be GSC IB, and this one would be GSC IC. And this theta would be this one. So it would be grid V underscore theta. Let's check. That's okay. And this one would be GSC underscore ID.
Sir, there is any change in ABC to DQ block?
Inside it properties?
Yes, sir, property.
No, there is no change. So done up till now. So now two
Sir,
ports
in
will see.
GSC,
Sorry.
last from tag, greet v underscore.
Grid B underscore theta. This signal itself. This tag itself. Grid B underscore theta. So now we'll take to termination block. I will make it still. So done up till now.
Sir, in GSC part, last one is go to GSC.
Yeah, GSC
Underscore.
underscore ID. I have just copied this both part and pasted it. Only thing I've changed the name. That's it.
Done, sir.
So that's it. Save this model and any queries regarding any part or any errors in your model, you can ask. Else we can end this session over here.
Sir, yesterday, sir asked us to create a to submit a report. But sir, what should be the format? Means what should we include in that report? In simply the screenshot of model and simulation and the SCADA panel as well as run, as well as the means execution of the simulation or anything else.
Schematic model initialization, script, then the SCADA panel, image, and then after settings, values, and then capture result for at least 1 second, so that you can show transients as well as steady state situation also. Okay.
Sir, we have to write the steps also and mention the values as well.
No, you don't need to write. You can keep the component values in the form of table and a measure. Not all the you don't need to write the values of all the components, but you need to write the values of this electrical part, plant part. Okay.
Okay, so values, we need to create a table stating the values of all the plant parts.
Yes, yes. Electrical part. Say just you have used source. So source is type of source and the value. Then filter values. Or if you means if you are designing your own model, so in that case you can hide the filter values and you can give the load values. If you are using motors, so motor parameters like kilowatt parameters and other parameters, but not need to mention all the parameters. Its reference is like that. It means how to prepare your chapter. You just means have you seen any research paper?
Yes, sir.
Similarly, you need to prepare your chapters.
And sir, chapter means weekly chapter will be
Yes,
or what?
chapter is going to be weekly, and you need to give them A, B, C, D, or 1, 2, 3, 4, 5. Because in a week we are trying to develop at least 4 to 5 models now. So in the weekly chapters, you need to put all the models and their means images like a schematic, SCADA. Those things you need to put. Actually, my idea of having this report is so that you all can learn that how to write a research paper. Okay.
Okay, sir. So it will be 5 chapters because 5 week.
5 weeks, chapters, one introductory chapter means about the Typhoon HIL, why you have chosen Typhoon HIL, and what are the benefits you are going to have with this one. Fine. And the last chapter is going to be for conclusion, and in conclusion, you need to write assignment. Means uh, you have completed these assignments, and you need to discuss about those assignments, because those models which you are going to put into assignments, those are created by you only. Those are not available in the example for them. Okay, so those are your outcome of this training. Okay.
Yes, sir. Thank you.
Okay, so I think we need to close the today's session, and we'll meet by tomorrow at the same
Sir,
time.
Any other queries? Yes.
sir. Sir,
Yes.
in last model, modeling and simulation of MPPT boost charger, I am not getting a SCADA output.
No issues. So Ripto, can ask
Present.
Praja to connect with Padmaja and resolve her queries.
Yes, sir, I'll see after it.
Okay. Is it fine, Padmaja?
Yes, sir.
Okay, so have some break, and after that, WhatsApp in the group to communicate with Mr. Praja, and then he will proceed you how